Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel, and today we're going to revisit the pressure relief valve with an increased sense of detail. Our objective is to reintroduce ourselves to the pressure control valve family, discuss vented and remote pressure relief valves, and additional pressure relief valve applications. This lecture operates under the assumption you're intimately familiar with the contents of the pressure relief valve lecture, available at the Big Bad Tech channel. If you haven't watched this lecture yet, or only dimly recall its contents, please take the time to do so now. The pressure relief valve, despite it being one of the earliest devices we discussed in this lecture series, is just one of a larger family of pressure control valves. Recall during the hydraulic schematics lecture, available at the Big Bad Tech channel, we briefly discussed this family on an introductory level. Pressure control valves look and behave astoundingly similar to one another. Pressure control valves, as the name implies, do something when pressure reaches a certain value. Pressure control valves come in 5 main types: pressure relief valves, sequence valves, counterbalance valves, pressure reducing valves, and unloading valves. When first introduced to this family en masse, you'll note they're hard to differentiate from one another. This being said, if you know what characteristics to look for, they're easy to distinguish and identify. The characteristics I use to classify them are as follows: pilot line, deactivated state, whether the valve has a check valve bypass or not, whether the drain is internal or external, and finally, location and perceived function. This might be a review of this topic. However, repeat exposure to this topic is pretty helpful. Pilot line. All pressure control valves monitor pressure using a dashed pilot port. Sometimes the pilot line is internal to the valve, or can be an external remote connection. Internal pilot lines can monitor the valve's input or primary port, as in the case of a pressure relief valve and certain configurations of sequence and counterbalance valves, or the internal pilot line can monitor the valve's output or secondary port, as in the case of pressure reducing valves. External or remote pilot lines can be found in the case of unloading valves and certain configurations of sequence and counterbalance valves. Deactivated state. All pressure control valves have a deactivated state. When pressure in the pilot line exceeds the adjustable set value, the valve actuates into its opposite state. Most of these valves are normally closed that open when pressure exceeds the set value, and, for all intents and purposes, operate just like an ordinary pressure relief valve. The exception to this characteristic being the pressure reducing valve. Pressure reducing valves are normally open, and when pressure exceeds the set value, the valve closes. That's a dead giveaway. Check valve bypasses. Some of these valves have check valve bypasses, some of them don't. The ones with check valve bypasses, like sequence, counterbalance, and pressure reducing valves, are designed to control pressure in one direction and then be bypassed in another. The ones without check valve bypasses, like pressure relief valves and unloading valves, are ordinarily employed in regions with unidirectional flow paths, rendering reverse operation a non-issue. Drain ports. Some of these valves necessitate external drains, some of them don't. The ones with external drains, like sequence and pressure reducing valves, have pressurized secondary ports. The ones with internal drains, like pressure relief, unloading, and counterbalance valves, are intended to operate with a secondary port at low pressure, rendering an external drain unnecessary. Location and perceived function. Finally, and most importantly, very often the location of a pressure control valve is a dead giveaway about the valve's true nature. Pressure relief valves are always between the pump and the tank. Unloading valves are also known to loiter around the pump. However, they're easily distinguishable from pressure relief valves since their pilot passage isn't internal to the valve, but rather a remote external connection. Sequence valves hang out around the input of actuators, as do pressure reducing valves. They're distinguishable from each other since sequence valves are normally closed and pressure reducing valves are normally open. Counterbalance valves are the opposite. They hang around the output of actuators. If location and perceived function still doesn't clue you in, sometimes the schematic includes specific port identifiers and goes to the trouble of directly referencing the valve in a legend. Long story short, anytime one of the pressure control valve quintuplets pop up, you should be able to run through the list: pilot line, deactivated state, check valve bypass, drain, and location and perceived function, and check off as many identifiable characteristics as possible. Sooner or later, you'll hit upon which valve you're looking at. Pressure relief valves, the topic of this particular lecture, are immediately recognizable as pressure control valves with an internal pilot line that monitors pressure on the input port. They are normally closed valves that open when pressure on the input port exceeds the adjustable set value. Pressure relief valves do not have a check valve bypass because they're employed in regions with unidirectional flow path, meaning reverse operation is a non-issue. Pressure relief valves have internal drains since their output port isn't pressurized. Finally, pressure relief valves are always between a pump and a tank, and their purpose is to limit maximum pressure of a larger hydraulic system. Let's now examine some additional pressure relief valve applications, specifically vented pressure relief valves, remote-controlled pressure relief valves, multi-pressure systems, and a cool related device called a crossover pressure relief valve. Let's examine vented and remote-controlled pressure relief valves first. However, before we do so, we need to briefly review the internal construction of a pilot-operated pressure relief valve. Recall during the pressure relief valve lecture, I included in the cutaway diagram of a pilot-operated pressure relief valve an extra passage known as a vent port, but told you to consider it blocked and ignore it until a later time. That later time is now upon us. If you remember correctly, a balanced piston-style pilot-operated pressure relief valve functions as follows. Fluid at pressure below the set value is conducted through a small orifice to both sides of the main spool. Given equal pressure on an equal surface area, the piston is balanced, and the added force of the bias spring holds the primary P2T passage closed. When pressure in the pilot chamber reaches the set value, the pilot dart unseats and drains the pilot chamber to tank. The balanced pressure condition on both sides of the main spool would be upset, and the primary passage would open, relieving pressure. When pressure drops to the reset value, the pilot dart reseats and pressure equalizes on both sides of the main spool. The added force of the bias spring holds the primary passage closed. Note the pilot-operated pressure relief valve operates on the principle of balance, and the pilot section's role is to selectively upset or maintain this balance. The vent port is simply an additional access point to the pilot section of a pilot-operated pressure relief valve. The vent port can therefore serve as a means of signaling the main pressure relief valve to open. The vent port is used for two primary functions. One as a safety or unloading vent, and two as a means of remotely operating the main pressure relief valve. Let's discuss venting first. Consider the simplest application of the vent port, that of a safety or unloading vent. In this application, a two-position, manually actuated directional control valve spring offset into the normally closed position is hooked between the vent port and the tank. Note the vent port connection on a pilot-operated pressure relief valve is often illustrated as a pilot connection to the adjustable spring. When this directional control valve is in the normally closed position, the vent port is blocked and the pilot-operated pressure relief valve functions as normally. Pressure will act as a load-induced phenomenon up to that of the main pressure relief valve. If, however, an operator witnessed a dangerous situation, or if an operator wished to unload the pump due to an extended stall period in the closed center position, they can immediately depressurize the system by manually actuating the two-position directional control valve into the open position. The open valve now exposes the vent port and thus the pilot chamber of the main pressure relief valve to tank pressure. Regardless of the pressure at the time of actuation, the balance condition is disturbed and the main pressure relief valve opens. Note the two-position directional control valve attached to the vent port only serves to signal the main pressure relief valve to open. It is not the one that is carrying the majority of relief flow. That responsibility still belongs to the main pressure relief valve. For example, if a pump is capable of supplying 8 gallons per minute of flow, the main pressure relief valve must be sized to accommodate this flow. The directional control valve serving to vent the main pressure relief valve, however, only needs to be sized to accommodate a tiny amount of pilot flow. Additionally, the directional control valve serving to vent the main pressure relief valve can be located at the point of use, whereas the main pressure relief valve can be located at the hydraulic power unit in some other room or in some other building. If the manual actuator on this additional directional control valve was an emergency button, this vented pressure relief valve therefore serve to ensure the safety of the operator and the system. The vent port on a pilot-operated pressure relief valve need not be an all-or-nothing scenario. Consider a remote-controlled pilot-operated pressure relief valve that, in place of a two-position normally closed directional control valve, has an additional remote pressure relief valve between it and the tank. This additional remote pressure relief valve serves a similar purpose as the safety vent. However, rather than being manually initiated, the venting action is automatically initiated at the request of the remote pressure relief valve. In this application, consider the main pressure relief valve as having a set value of 800 psi, and the remote pressure relief valve as having a set value of 600 psi. At pressures below 600 psi, both valves are closed and pressure is a load-induced phenomenon. If, however, pressure rises above 600 psi, the remote pressure relief valve opens and exposes the vent port and thus the pilot chamber of the main pressure relief valve to tank pressure. The balance condition is again disturbed and the main pressure relief valve opens. As previously, note the remote pressure relief valve attached to the vent port only serves to signal the main pressure relief valve to open. It is not the one that is carrying the majority of relief flow. That responsibility still belongs to the main pressure relief valve. Additionally, the remote pressure relief valve serving to remotely control the main pressure relief valve can be located at the point of use, offering an operator the opportunity to fine-tune pressure at the point of use without the necessity of adjusting the main pressure relief valve. Note, a remote-controlled pressure relief valve can only regulate pressure downwards from that of the main pressure relief valve, not upwards. The main pressure relief valve is typically set at the maximum pressure an operator would ever need, and the remote pressure relief valve is used to adjust pressure down from there. That's about it for vented and remote pressure relief valve applications. Let's move on to a discussion on multi-pressure systems. A multi-pressure system is a system that can operate the same actuator at different pressures. Multi-pressure systems can be used to perform the same action on different materials, necessitating different levels of force, or perhaps a system that needs to exert different levels of force during the same cycle. Multi-pressure systems can be created with a collection of pressure relief valves and an additional directional control valve. In this application, solenoid-operated directional control valve 1 acts as a pressure selector. Note it has a blocked port symbolized by an X. The solenoid-operated directional control valve 2 acts to extend or retract the cylinder. Let's say the main pressure relief valve is set to 1000 psi, pressure relief valve 2 is set to 500 psi, and pressure relief valve 3 is set to 250 psi. When neither solenoid of directional control valve 1 is actuated, given the closed center, the system pressure is limited to that of the main pressure relief valve, 1000 psi. Directional control valve 2 could be actuated to perhaps stamp some symbol on a durable material like metal. Let's say you're out of metal, and the next best choice of raw material is wood. The multi-pressure system allows this flexibility. When solenoid A of directional control valve 1 is energized, the connection to pressure relief valve 2 overrides pressure relief valve 1 and ensures system pressure is limited to that of pressure relief valve 2, in this case 500 psi. Directional control valve 2 could be actuated without damaging the less durable material. Finally, let's say we're short on both metal and wood, and the next best choice of raw material is cheese. When only solenoid B of directional control valve 1 is energized, the connection to pressure relief valve 3 overrides both the main pressure relief valve and pressure relief valve 2 and ensures the system pressure is limited to that of pressure relief valve 3, in this case 250 psi. Directional control valve 2 could be actuated without damaging the significantly less durable material. Consider this same multi-pressure system used in an ever so slightly different manner. Let's say we're trying to extract oil from some agricultural, mineral, or animal product. If we put the product in the press at the maximum pressure right up front, we might run the risk of damaging it. For this reason, we initiate operation with solenoid B of directional control valve 1 energized. The connection to pressure relief valve 3 serves to override both the main pressure relief valve and pressure relief valve 2, ensures the system pressure is limited to that of pressure relief valve 3, in this case 250 psi. Directional control valve 2 can be actuated to gently compress the product. a reasonable quantity of oil starts filling our collection tank. After a period of extended compression, the flow of oil decreases to a trickle. While directional control valve 2 maintains the extended press cylinder, solenoid B is de-energized and solenoid A is energized on directional control valve 1, our pressure selector valve. The connection to pressure relief valve 2 serves to override the main pressure relief valve and ensures system pressure is limited to that of pressure relief valve 2, in this case 500 psi. The press cylinder exerts twice the force and the flow of oil increases. After a period of extended compression, the flow of oil decreases to a trickle. Finally, directional control valve 2 can maintain the extended press cylinder. At the same time, both solenoids of directional control valve are de-energized. The closed center position in directional control valve 1 hands off control to the main pressure relief valve. The pressure-induced force on the press cylinder doubles yet again, and the flow of oil increases until all of it is extracted. The staged progressive increase in pressure using the multi-pressure system ensured the maximum quantity of oil was extracted without damaging the product. And to top it off, when the press cylinder is retracted, you've got an attractive whale-shaped rug that's sure to be the next big thing in interior design. Let us now briefly discuss yet another related pressure relief valve application, that of a crossover pressure relief valve. Crossover pressure relief valves are commonly associated with hydraulic motors and necessitate a little lead-up discussion to appreciate their worth. Consider a hydraulic motor in the act of rotating. When flow suddenly stops, the inertia of the rotor and driven load continues to rotate the shaft as if it were a pump. Given a closed center position directional control valve or an otherwise blocked port, the oil pumped by this action slams to a stop and pressure spikes. The faster the motor and the heavier the driven load, the greater the pressure spike. This pressure spike can damage the motor, the directional control valve, hoses, and fittings. Additionally, the inlet port would experience a partial vacuum condition and can cavitate just like a pump starved of fluid during the suction phase. Both these regrettable scenarios, the pressure spike at the outlet and cavitation at the input, are often called shifting shock. To solve this problem, sometimes a float center valve is used to de-energize a spinning hydraulic motor. When the valve is moved to the float center position, flow doesn't slam to a halt, but rather the hydraulic motor freewheels to a halt. For this reason, you'll sometimes hear float center valves called motor center valves. In the float or motor center, only time and friction serve to slow the motor and applied load. While suitable for some applications, this might not be the best course of action for loads that need to limit pressure spikes, yet still be braked in a reasonable amount of time. Consider two pressure relief valves connected in parallel to the actuator ports. Note the opposing inlet and outlet ports. This relationship is sometimes known as reverse parallel or anti-parallel. Additionally, note the enclosure symbol surrounding the two valves. The enclosure symbol indicates that these two valves are in fact the same device. This single device is known as a crossover pressure relief valve. Despite the name pressure relief valve in the title, it's not a true pressure relief valve in that it does not limit maximum system pressure, but it does serve to limit pressure in this particular actuator branch. It shouldn't be hard to predict how a crossover pressure relief valve works to cushion the stop of a hydraulic motor. In summary, the individual pressure relief valves basically serve as float or motor center pathways when pressure is above the set point of the crossover pressure relief valve. When pressure is in excess of this set point, the valve opens and the motor continues to spin, alleviating further pressure rise. When the pressure spike subsides, the valve closes and brings the motor to a halt. If the inertia of the applied load continues to rotate the motor and pump fluid, the valves flutter open and close, eventually bringing the motor to a progressive halt. Note the reverse parallel relationship ensures the motor can operate and be braked in either rotational direction. The set value of crossover pressure relief valves must be high enough that they don't open during regular operation of the motor, yet low enough to provide sufficient cushion and shock absorption. Additionally, crossover pressure relief valves should be installed close to the motor as possible to allow for faster response. Alright, that's about it. Other lectures examine the remaining members of the pressure control valve family in greater detail. Until then, that's all I've got for you. In conclusion, this lecture reacquainted ourselves with the larger pressure control valve family and revisited the pressure relief valve in greater detail. We discussed vented and remote-controlled pressure relief valves, multi-pressure systems, and a related device known as a crossover pressure relief valve. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.